Now let us see what do we mean by the word stress. Stress is defined as the force per unit area within material that arises from external applied forces, uneven bending or permanent deformation that will permit an accurate description and prediction of elastic, plastic and fluid behavior. Right, so this is stress. When deforming forces are applied on a body, the force of reaction, internal restoring forces developed to bring back the body to its original position, and this is known as stress. Stress is represented by restoring forces per unit cross-sectional area, right? And under equilibrium condition, stress is equals to deforming force per unit area of cross section. Now, let us see what do we mean by stress and its different components. So, there are three different types of stress: normal stress, shear stress and bulk stress. Normal stress is further classified into tensile and compressive stress, right? So, when we talk about normal stress, we should understand that it is a stress which is applied normal to the body, right? If deforming force is applied normal to the area, then it is termed as normal stress. What about the tensile stress then? Tensile stress is a stress when the body is subjected to pull, right? When a force is applied to pull, then it is a tensile stress, and it is also known as a longitudinal stress. The third one is a compressive stress. So, what do we mean by a compressive stress? A compressive stress is occur due to compression or compressive action. Clear? So, in this, the length decreases, object length decreases or gets shortened, right? Then there is a shear stress. So, what is shear stress? When the stress is tangential to the surface due to application of forces, then it is termed as shear stress. And when the normal forces changes the volume of any body, then it is termed as bulk stress, right? So, these are different types of stress. Now coming to strain. So, what do we mean by strain? Strain is basically amount of deformation experienced by the body in the direction of applied force divided by initial dimension of the body. Strain is equals to elongation per unit original length. Strain is of three types: longitudinal, shearing and volume strain. Now coming to the next one, which is our Hooke's law, right? So, let us see. Here the Hooke's law will form a relationship between stress and strain. Hooke's law states that the strain of the material is proportional to applied stress within the elastic limit of the material. Again, I am repeating, the strain of the material is proportional to applied stress within the elastic limit of the material, and it is represented by F equals to minus K into X, where F is the force, X is the extension of length, that is change in length, and K is our proportionality constant, which is a spring constant. and it is given in terms of Newton per meter. Now coming to the next topic, which is stress strain diagram. This is again very important to understand what do we mean by stress strain diagram. The material stress strain diagram or curve gives a relationship between its stress and strain at any given point. Here you can see in the figure, we are having strain in our x-axis and stress in our y-axis. Right, A, B, C, D and E are different points. So at each point, what is the relationship between stress and strain is given here. So there are different points like proportional limits, elastic limit, lower yield point, breaking stress and fracture point. So in each of this point, how elasticity of material differ from one to different point is demonstrated. In proportional limit, in this particular point or in this particular region, it is the region in stress strain curve that will obey Hooke's law. So in this particular region, dark blue one, in this particular A point, in this region, Hooke's law will be followed, right? So the stress strain ratio gives us a proportionality constant known as Young's modulus. So point O to A will follow a Young's modulus. Then coming to point number B, which is our elastic limit. So in this point, the material returns to its original position when the load is removed. Right, from point A to B, if we will remove the load, the material will come back to its original position. Then coming to the third point, which is lower yield point. So in this particular point, the material will start to deform physically. Even if you will remove the load, there is some permanent deformation which will be experienced by that particular body. Then there is a breaking stress. So it is termed as ultimate stress point. It is a point that represents maximum stress that a material can endure before failure. Right, maximum stress which a material can endure before its failure. And the last one is point number E, which is fracture point. It is the point where material will collapse. Right, so this is advantage of using stress strain curve. We can have stress strain curve for different materials, for different metals, and we can see in which limit or in which portion we can utilize or use that particular material. Now coming to properties of material. First property is ductility. Ductility is basically measure of amount of deformation any material can withstand before breaking, right? Any material can withstand how much amount of deformation before it goes into a breaking point is termed as ductility. The next point is brittleness. So brittleness is basically a property by virtue of which a material breaks easily under the action of shock or load without appreciable amount. Brittleness is a property due to which a material can easily break. It is a brittle material, right? The next property is plasticity. So what do we mean by the word plasticity? Property of a material by virtue of which it will undergo permanent deformation, right? When a material is subjected to external load of such magnitude that deformation continues with no apparent further increase in load, the material is said to have become plastic. Now, this is an elastic behavior of solid. So, what do we mean by elastic behavior of solid? In a solid, we all know that each and every atoms or molecules are surrounded by another atoms or molecules, and these are bonded together with some intermolecular forces or interatomic forces which are at equilibrium position. We know about this, right? But when a solid is deformed, the atoms or molecules are displaced from their equilibrium position causing change in interatomic forces and change in distance, right? And when the deforming forces is removed, the interatomic forces tends to drive them back to original shape or position. This is the elastic behavior of solid. Now, what do we understand by the terminology elastic after effect? It is basically a delay in recovering back original condition on removing the deforming force, right? Delay in recovering back original condition when we remove the deforming forces is termed as elastic after effect. So what is elastic hysteresis? It is the lagging of strain behind the stress in any property. Coming to elastic fatigue. So it is defined as temporary loss of elastic properties because of action of alternative deforming forces. Now let us see what do we understand by the word working stress and factor of safety. Working stress is given by ultimate strength upon factor of safety, and this formula is used for brittle materials. And if we want to determine working stress for ductile material, we must determine first yield strength and then divide it with factor of safety. So first thing comes into our mind, how to determine factor of safety. For determining factor of safety, we should first determine ultimate stress. So factor of safety is determined using maximum stress divided by working or design stress. And factor of safety for brittle material is given by ultimate stress divided by working or design stress. And for ductile material, we are using here yield stress divided by again working or design stress. So I just hope the topic which we have covered today is quite clear. Thank you.